Okay, the next topic is regular expressions in Scala. Let's take an example first. Here, the is a string the, and then if we just say dot r, Scala understands that we are talking about the regular expression which represents this word the. And then if we want to search for that regular expression, in other words this pattern the in a string, we can use the find all in method as available in Scala regular expression and pass this string in which we want to search that pattern. And maybe it's a good idea for me to run this piece of code on Scala console, and let's see what we get from there. Let me clear this up, and to do that I can quickly do this, and this is the Scala console, and we see we get a regular expression which represents the. And now the second piece of code was to find all occurrence of this pattern in that phrase, the way the scissor streams run it, and we get an iterator. And to know more detail, maybe it's a good idea to store this in a variable. And now I can say x to list to see what patterns we found in this phrase which matches with this. And we see we found this word and this word in this phrase because it is here and also it is here. So hopefully this shows you how to use a regular expression and how to find all occurrences of that regular expression in a given bunch of words. Okay, now let's come back. And let's take another example. This is regarding numbers. So this means any digit from 0 to 9, and plus means occurring one or multiple times. So that basically represents all integers, right? And then again dot r means the regular expression which represents this pattern. And now we can have one sentence which is this, representing an address, and we can see there are two places where numbers appear. We may want to know which places in this address numbers appear, so we can do that using this regular expression which we got here. And then maybe first we want to find what is the first place where this regular expression appears in address. So we say num regex dot find first in this address, and that should give us this 423, correct? Maybe here also I should run this piece of code. So let's do it quickly. This is my regular expression, and then this is the address, and after that this is the match first, and that gives us this first occurrence, but that is packaged under sum, because in some other case there may not be any match, and in that case we need to return none, right? So we understand why sum is important in such situation. Okay, now let's come back, and we were here, and of course we also can find all occurrence of that number. Now that means I can do this, and that is here, find all in address, that gives us an iterator. And if we say matches to list, and that shows that 423 is the first one and 501 in the next match. Okay. And here it shows the general forms. Basically it follows Java regex format, and the meaning of a b question mark is a followed by a possible b. So that means b can be there or b may not be there, and that is happening because of this question mark. So b question mark basically means b can be there or b may not be there. So that means in summary, this regular expression corresponds to a pattern where a should be there or a must be there, and then b can be there or b may not be there. Okay, the next format that corresponds to any decimal integer, because slash d corresponds to one decimal digit and plus means that digit occurs one or multiple times. So overall this pattern represents all decimal numbers. Now to match with any dictionary word, which is basically any combination of small letter and capital letter, these pattern, that A to Z or capital A to Z in a pair of brackets, that basically means any character. Similarly, slash W means any character, and then after that if we say plus, that means that character appears one or multiple times. So overall this part basically means any word, or alternatively this and then a plus means any word. Now this one is a pattern for matching with any decimal number, which can have an integer part and a decimal and a decimal part. Now see that this question mark basically means this decimal or decimal part may be there or may not be there, but this part has to be there, that some digits. And this minus question mark means it can be a negative number, or a negative sign may not be there, right? So overall this means any decimal number. Okay, some examples. So same pattern, and after that if you say .r, that basically makes you ready with this regular expression. And remember, you need to use triple quote to use all features of regular expression. Now after getting this pattern, if we try to find the first match of this pattern in this phrase, this should be the answer, right? Packaged in sum. Similarly, if we try to find all matches, then if we also convert that to a string and then concatenate each of those pieces in comma, then this will be the result. That is the first match, comma, second match, comma, third match concatenated as a string. Another example, this is the pattern. The pair of bracket always means the inner characters, they are alternatives. So that means this can be either C or S, and then that is followed by E, then slash T means this is a digit, right, one digit, and plus means one or multiple digits. Now if we try to find the match of this pattern in this sentence, uh, what do we expect? Will this match? This matches with this part, but this does not match, right? So overall, this word does not match with this pattern, but this matches with pattern with C, this matches with pattern with C, and this digit part is there. So if we want to find all matches concatenated with comma, then that should be the answer, correct? And remember that this does not come in answer. Another example, this one means any character, right? /w means any character which appears in an English word, that means small character or large capital characters. Star means that can appear 0 or multiple times, and then followed by N, followed by O, and then U is optional. Question mark makes U is optional, right? And then followed by R. Now we understand that in this sentence, this honor is the British honor that matches with this, and Americans honor also matches with this, right? So the answer of this should be this one. Now there is a concept of greedy and lazy matching in Scala regex. Let's explain it with an example. So this means any integer, right, as we discussed before. And let's say this is a integer in form of string, and then we are trying to match, trying to find the first match. As far as we saw in the previous slides, the answer will be this one, right? Because this pattern matches with one or multiple digits, that means this. So this whole digit, whole number becomes the answer. But from some application, it may be advantageous to get only the first digit and all other matches, and then the concept of lazy match appears, and to enable lazy match we have to use this question mark after the pattern, and in that case after the first digit matches with this pattern, the matching will stop. It will not consume the subsequent characters. Okay, so that is the concept of lazy match. More inline modifiers to make the regex more powerful. Now to make this pattern case insensitive, we can use question mark I, that's an inline modifier, and then with this phrase, if we try to match try to get the first match of this pattern, then this will be the match even if this is a small g. And another situation appears when the string which we are trying to find some pattern in has multiple lines. This is the first line, then a new line character, and second line. So it is necessary to have a pattern where we can go over multiple lines. So that means this dot star, dot means any character, dot star means 0 times dot or multiple times dot, that should consume any character including new line, and that mode can be enabled by question mark S, and that's called dot all mode. You can Google little bit scala regex dot all mode to get more information. So in summary, when we are trying to get the first match of this pattern in this phrase which has multiple lines, that works, and we will see that this pattern is matching with this. So that means the dot star is consuming from here to here. right? All of these characters are matching with this dot star, including this new line. Think about it. It's interesting. Similarly, this is a pattern where this is case insensitive, and S means dot all mode. So this is the couple of sentences where capital R is there, rich, and new line is there. This is small p, poor is there, and we are trying to match. Then there we will find a match, and this should be the answer, right? Even if there is a new line, that will be matching with the dot star. Now things get more interesting. Let's think about how we can access a web page using a URL, right? So https www.bbc.com is an URL, and so for some reason we want to grab the whole web page, that HTML document, by program. So we want to write a piece of code which can be just this one, and supply the URL and say dot make string. So this Scala library source will read this whole web page, and then dot make string will make it a string and return to us, and that will be available as page. Okay. Now say we are interested to see how many page links are present in this web page bbc.com. bbc.com, if you just go there, it's a web page, and any normal web page can have multiple other links to click, multiple other web pages to click, right? Say for some reason I want to know about all those links present in bbc.com. How to do that? So first of all, I need a pattern how to represent this how to represent an HTML link right, as present in a web page, and this can be the pattern to represent a link. Okay, so maybe I show a little more so that I see an example. So here in a web page, you can have a link like this. This is just to show you how the link information in a web page look like. And now try to match this with this pattern. So a matching href, and that is matching, correct, and then http dot plus question mark, that means it can match with http as well as https because of this lazy matching situation, right, we talked about. So this will match with this part, and then www.bbc.com, that will be consumed by this because dot star means everything, and this arrow, I should say angular bracket, is matching with that, right? And then this part will be corresponding to this dot plus, right, dot, that means any bunch of characters, and then this part is matching with this, right? So this is just an example how a link in a web page, in an HTML web page looks like, and how we can have regex for that. Okay, and this is also is there, and don't forget that dot art thing, right? So after getting that link, we want to see how many matches are there of that link in the page. So again, remember our task is we want to know how many links are present in bbc.com. So we already got the page, web page, HTML page of bbc.com, which is here. We already got a regex of the link. Now we are trying to find all matches of that pattern in the page, which will basically give us all information about all the links present in bbc.com. and then some Scala regex libraries tools will convert it to a list, and dot size can tell us how many such links are present there. So this means 84 links are present in bbc.com, and see the power. Just writing this one line, first we are getting the web page programmatically, then writing another 2 lines, we are getting how many links are present. See the power. I mean, how we can process a web page. That can show you how web crawler works. So this Google has this huge powerful crawler, right? I mean, you can see some of these elements here to see how to write a web crawler. Okay, and then if you want to see the first match, you can just say to list the first item, and that will give you this first match with this pattern, right? Basically, this gives you the information about the first link. And now if you want to get only this URL part, not this whole thing starting with A and ending with A, if you want to get only this URL part, that is also easy. So remember, in the regex we have used some pair of parentheses. One is here and another one is here. The idea of using pair of parentheses is this part is group 1 and this part is group 2. So that means the part of the link which matches with this part, we can separate that part out just by accessing group 1 part from the previous result, and that basically gives us all the URLs present in all these 84 matches. And if you want to get only this one, then that means that is the first item in those URLs, and you can access that using link 0. Correct? Maybe it's a good idea to run this piece of code. That may give us some more confidence or some more information. So let me first run this code. That means maybe I clear things out, and here just in this one line we are accessing this whole bbc.com web page, and that has happened. And that whole string, which is an HTML page, ... means it's a huge thing. We are not showing the whole page here, but that page is now present in this variable page, right? Okay, we got it. Now let's define this regular expression, which is here, that represents a link in that page, right? And now we want to see how many such links are present in that web page which you have just got, and that is 79. A little bit different from what the PPT shows, which was maybe 1 year old. bbc.com has changed in last 1 year, it seems. And then we want to get the first link information, and that can give us that, and that is from here to here. But now we want to get only the URL part. So how we are doing it? Using this group concept, group 1, we are getting all those URLs in those 79 ... means more. All those 79 URLs are in group 1 and they are present in links. So now if you want to get on just the first one, and that you can get by that, right? So it seems the bbc.com web page also has a link to self bbc.com. Okay, that's good. And remember that uh, for some web page, when you are trying to access that page, you may get an error. Basically, Scala can raise some exception if some hidden character is there, which your default setting may not be able to process. And in that case, you may use some extra parameter with this from URL method, not only URL like here, but give an extra parameter which is an ISO code, and that will take care of those hidden characters. Okay. Now we talked about the regex of a link, and here we show that there can be multiple variants of the regex, simpler to more complicated. But for simplicity, as we just talked about this one, let's just focus on that one for the link. Now you may be also interested to know how images are presented in an HTML page, right? And image in an HTML page always starts with img tag, and this is the full regex for that. Okay. And there are also more than one variant, and let's just focus on this variant where image tag is there and source of image, that means where the image is available, the file source that is present here. Similarly, the web page also may have some script, and that will have this sort of tags, and we may be also interested in the regex of a script as shown in a web page, so that we can do some processing automatically. Okay,